Assalamualaikum and salam Malaysia Madani. Thank you and very welcome to our presentation today. We are from Group 5 that consisting of 5 persons from us, which is me, Rafida binti Maidin, Rizal, Zulhami, Shahrul and Shahrizan. As you can see on the screen, our topic today is fish vaccine in aquaculture. First of all, I'd like to give you an overview of aquaculture vaccination. Aquaculture is a fast growing industry critical for meeting global seafood demand. However, disease outbreaks pose challenges to sustainability. Vaccinations plays a crucial role in disease prevention and control, protecting farm creature and ensuring long-term viability. This review provides an overview of vaccines used in aquaculture, including disease management and immunological responses. Different types of vaccines and administration methods are explored, along with the benefits and considerations.
Hi, hello everyone. My name is Muhammad Rizal bin Suraji. I will give you introduction about vaccine in aquaculture. Aquaculture, which involves the farming of aquatic organisms such as fish, shellfish, and plants, has become a crucial industry in meeting the growing global demand for seafood. As wild fish stock decline and traditional fishing methods face environmental challenges, aquaculture offers a sustainable solution for seafood production. However, the intensification and expansion of aquaculture operation have led to various issues with infectious disease posing a significant threat to industry long-term viability and productivity. The objective of this review is to provide comprehensive examination of the use vaccine in aquaculture, focusing of disease management and sustainable production. The review emphasizes the importance of vaccination mitigation, the various disease challenges faced by the aquaculture industry. It also explored different types of aquaculture vaccine, the mechanism of action, and the effectiveness in various aquaculture settings. Understanding the properties and benefit of the different vaccine types is crucial for their successful use in disease prevention efforts. Aquaculture vaccination is crucial for disease prevention and sustainable production, offering protective immunity to farm organisms and reducing economic losses and environmental impact. However, challenges such as vaccine development, effectiveness, regulatory framework, and public acceptance must be addressed to promote wider adoption and successful implementation.
Disease challenge in aquaculture. Infectious issues in aquaculture pose substantial hazard to the industry sustainability and output. Aquaculture organisms such as fish, shellfish, and crustaceans are vulnerable to the variety of infectious illness caused by bacteria, viruses, parasites, and fungi. The illness can cause significant economic losses, have a negative influence in the environment, and even jeopardize our food security. High stocking density and close contact of farm organisms are two of the key causes of disease outbreak in aquaculture. Aquaculture facility frequently house of the large number of people in cramped place. Um, Creating an environment such susceptible to pathogen transmission. When a disease causing organism enter the system, it can quickly spread, infecting a large proportion of the population in the short period of the time. Disease propagation has also been aided by mobility of live fish and the globalization of the aquaculture trade. As fish transport across the new place increase, this transportation of live fish have the potential to spread the pathogen, especially if the suitable biosecurity control are not in the place. The additionally, intensifying aquaculture methods such as the use of the high nutrient feed and changing water parameters can impose stress on farm organism, impairing their immune system and making them more susceptible to disease. Stressor can be decrease the immune response, making infection more likely to establish themselves and cause disease. Disease outbreak in aquaculture can have serious consequences. High disease death rate might result in severe financial losses for farmers. Loss may include cost of loss of stock, expenses for disease diagnosis and treatment, and the possibility of the dismissed production and market value. Disease outbreak can have negative environmental consequences in addition to the economic costs. The use of therapeutic treatment to control disease, such as antibiotic or chemotherapeutic, might result in the leakage of this compound into the surrounding aquatic environment, potentially causing harm to non-targeted organisms and contributing to the development of the antimicrobial resistance. That's all.
Hi, I will talk about the vaccine type in administration. So, as you know, aquaculture vaccine vary based on a target pathogen, host species, and desired immune response. In aquaculture, vaccine used to be protect the fish and also other aquatic organism from a disease. The choice of the vaccine depend on specific pathogen being targeted. So the host species can be protected and the desired immune response for the fish. Bacterial vaccine use either inactivated the whole cell or specific component to simulate immune recognition and response in the host. In this case, bacteria that cause the disease are obtained and modified to no longer able to cause the disease, but they still can contain component that can simulate the host immune response. So the bacterial vaccine help develop specific immune protection against the bacterial pathogen. Viral vaccine can be inactivated, attenuated, subunit based, or DNA based, depending on the virus and the desired immune response. A virus used in vaccine are typically modified to be harmless or not to cause severe disease, while still processing characteristics that can simulate the immune response. Viral vaccine activate the host immune system to recognize and fight against the actual virus in the fish or the aquatic organism is exposed to a real infection. Then we go to the parasite infection. Parasite infection pose a unique challenge in vaccines development, where although the effective vaccine for parasite are still in the process of being developed, there is the hope that promising the vaccine can be developed in the future. Parasite vaccine aim to develop an immune response that can prevent infection to reduce the severity of disease caused by specific parasite. We're going to the vaccine administration. Method include the injection, immersion, or oral delivery, depending on the fish species, fish size, and fish composite. Injection is typically used for the large fish, while the emulsion or the oral delivery is used for the smaller fish or the species that are more sensitive to injection. Each administration method has advantage and disadvantage, and the selection of the method depends on a factor such suitability of the fish species for fish size and type of the fish, type of the fish of the vaccine being used. Last part, proper vaccine handling, storage, and the timing of the administration are crucial to ensure vaccine efficacy. Vaccine should be handled carefully to maintain the integrity of the effectiveness of the uh, uh, active ingredient. A proper storage in the appropriate temperature and the condition is also necessary to maintain the vaccine stability. Additionally, timing and the administration of the vaccine is important, as the administration at the right time in the life cycle of the fish or aquatic organism can be enhanced to immune response and the protective effect of the vaccine. Okay, thank you.
The benefit of aquaculture vaccination is there are 3 points in here. The first point, vaccination reduce disease incidence, mortality rates, and economic loss in aquaculture. The second point is vaccine improve animal welfare, decrease reliance on antibiotics, and promote sustainable practice. The third point is vaccination contributes to responsible antimicrobial management and environmental conservation.
And for the challenges and future direction, regulatory approval and standardization of vaccination protocol are also required to ensure the safety and efficiency of aquaculture vaccine. Regulatory framework must be in place to review and monitor vaccination quality, safety, effectiveness, giving farmer and consumer confidence. Public acceptability and understanding of this vaccination are also crucial as public concern about vaccine safety and environmental impact can affect the adoption of aquaculture vaccination tactic. Collaboration between researchers, vaccine manufacturer, and aquaculture producer is essential to overcome these challenges. Efforts should be directed toward creating effective vaccine against major pathogen, developing vaccine formulation and investigation novel vaccine delivery modality to address the issue and increase the accessibility and effectiveness of this vaccine. More study and funding are needed to vaccine development, formulation optimize and novel delivery technique. Education and outreach program should also be implemented to increase public accept for office vaccination and raise awareness of its advantage for disease prevention, animal welfare, and sustainable aquaculture practice. Education and outreach activity are also important in spread the word about the benefit of vaccination and resolve public concern involving stakeholders, including as the aquaculture producer, regulator, and consumer can assist create the greater understanding of vaccine role in disease control and sustainable aquaculture operation, communication efforts, stressing vaccine safety, efficiency, and environmental advantage can assist stakeholders gain trust and acceptance. And for the conclusion, vaccine play a vital role in disease management and the promotion of sustainable production in aquaculture. Therefore, an effective and proactive approach to prevent and control infection disease, reducing production losses, improving animal welfare, and minimize the environmental impact of disease outbreak. Different types of vaccine, including bacteria, viral, and parasite vaccine, have been developed and show promise in controlling disease in aquaculture. However, the widespread adoption and application of this vaccine still face obstacles such as the lack of vaccine that target specific pathogen, and ongoing research is required to create efficient vaccine for disease with high economic impact. For small-scale farmer, cost effectiveness, vaccine distribution logistic, and administration technique are crucial factors to take into account. Successful vaccine implementation require regulatory approval, standardization of vaccination producers, and addressing public safety and environmental impact concern. Vaccine help to ensure the welfare of farm fish, reduce environmental impact, and support the economic viability of the aquaculture industry. Thank you.